Welcome to this intro to the basics of Solidity programming. This is going to be the start of a series where we'll look at understanding Solidity code, using hardhat for development and writing tests, deploying a contract, interfacing with other protocols, and eventually creating a front end to complete a full stack decentralized application. We're going to start off by opening up Remix, which is a commonly used in-browser Ethereum IDE, although there is a desktop version if you would prefer running it locally. Remix is an open source tool. It's designed to be used for writing, compiling, and debugging Solidity code. So this is nice because we can get started writing some code right away without having to install or set anything up first. It also has a variety of different libraries and plugins, such as the Learn ETH plugin, that you can enable to help you learn about both Solidity and Remix features while you're working if you want to. The Remix IDE has several modules, which you'll see here, including testing, debugging, and deploying. We can see they have some example contracts over here on the sidebar. There's an example of a test file as well. So if we come over here and we compile this contract, and then we head over here and click deploy, it's actually going to deploy this contract to a test network. Now you can even connect a wallet and actually deploy directly to mainnet from Remix if you want to as well. And then you can actually use this as kind of a mini front end over here in the sidebar to interact with the functions in your contract, which we'll come back to. But before we go any further, let's start going over some of the key points we need to know about Solidity. So Solidity was influenced by C++, Python, and JavaScript. So if you're familiar with one of those, you might notice some similarities. It is a statically typed and object-oriented programming language. It's set up to run inside the Ethereum virtual machine, or EVM, which is a runtime environment on the Ethereum blockchain. The EVM is sandboxed and completely isolated. So code running on the EVM has no access to network or file system or anything like that. So that's important to keep in mind. It's also good to remember that Solidity is fairly new, and so it is updated pretty frequently and occasionally has breaking changes. So looking back at these contracts, you might have noticed at the top it always starts with pragma solidity and a version number. And pragma is just a directive that specifies the compiler version that needs to be used for the current Solidity file, since it is subject to so many continuous improvements. A basic contract structure might look something like this. As far as actual syntax goes, Solidity contracts are basically like a class in any other object-oriented programming language. They contain data as state variables and then functions which can modify those variables. Because Solidity is a statically typed language, this means that the type of each variable has to be specified, and Solidity provides several basic types that can also be combined to form more complex types. It's important to note that the concept of undefined or null values does not exist in Solidity. So newly declared variables are always going to be initialized with a default value depending on their type. Solidity data types can be classified as either value or reference type, depending on the data location. So if a variable stores its own data, it's a value type. And if it stores the location of the data, it's considered a reference type. These types can include booleans with a value of true or false, integers, which can be signed and unsigned integers of various sizes. So we use keywords such as uint8 to uint256 in steps of 8 bits. Address, which holds a 20-byte value, the size of an Ethereum address. Strings, and arrays, which can be static or dynamic depending on whether you will need to add or remove elements from the array. And a mapping type, which acts like a hash table to store data in the form of key-value pairs, where the key can be any of the built-in non-reference data types and the value side can be of any type. There's also a struct type that you can use to define new custom types of your own. Now that we know all this, in the next video we can talk about functions in Solidity, explaining what getters and setters are, as well as the different function visibility types and modifiers. And we'll start writing some simple functions in a Solidity contract.